Okay, so here, this one, we solved this problem. The topic was to find the internal force for each member, right? So we found this, most of them. There was one member, this one, we had to use this point, point B, use which equation, remember? To find the forces in method of joints. Huh? Yes, summation of forces in X, Y. You just, in the method of joint, you have to pick a joint and then use f of x and y 0 to find the those unknown forces. Okay? Because we don't have moment. The forces are concurrent, they are originating from one point, then there is no rotation. So I'm going to do one more problem here, then I will have the class activity. Oh, yes.
We never finished this problem. We stopped at something.
Point B.
Yeah, you say we're gonna finish it then.
How many, which one was it? Which force was it?
That's the last one.
Yes, point B. May I have this one? I'm going to see,
Everything is not great on that.
Point C. DV. I think there was only one member that we had to find the force. DV, we have it, right? 4. How about this one?
We solved for
BC.
5.02.
No, I cannot find BC here. But I think we found BC, right? Yeah, we found BC, by solving this two equations. There were two equations, two unknown, and BC and DC. We found BC and DC from these two equations. Do you have a? Can I have? Yes, BC is there. We see BC is 5.02. This one, BC. You have it. And then what else? The DA. We also found it. I'm gonna write it here. You can, check the video, recorded lecture. DA is 4.09 K and T tension. Then BC is 5.02 Kn, and that is BC tension. No, compression. This should be C. What else? D, A, D, C. DC is 4. This is 2. also we found this one, AD. AD, yes. BC and DB. I think we found, BD, it's not. What is BD?
Well, that's where we last left off.
Okay. So we need BD and then A, B. So these are two unknown we need. Okay. BD is here. We can use this point. It's gonna be this direction, this one. This is point D. What's this force? This is DAD, and this one is DC. AD is 4 point. We can use 4.1. This is instead of 4.01. I can we can round it up, and this one is 4.1. So we have to find this one. What is the angle? Angle, let me use a different color. So finding this angle now, it's the trick. The angle, then it requires trigonometry back from high school. So look, this is 30 degrees, right? You need angle between this one and horizontal line. What is it? Put this horizontal line. What is this one? Interior alternate angle, right? So it should be 30. Same thing here. It should be 30. So now we can put that in a 30-degree angle. Then use fx 0 and fy 0. So AD times what? AD times cosine, right? Cosine 30 minus. It's going this direction. How about this one? This is positive. DC times cosine 30 equals 0. Because these two angles are the same, right? So if this is symmetric, you can say AD and DC, they have to be the same. Sometimes you don't need to do this calculation by looking at it, but it's better to prove it. And AD will be as same as DC. Agree, everyone? What is next? Next step. Well, are we done? No, because these are still unknown. You have to go further and use the next one, Fy, for that point.
AD and DC are not on.
Oh, by the way, yeah, these are for one point. We have it, and that is we have to use this one to find this unknown, right? Idea was to find this one. So what is the force here? The number is dB, right? dB is pure vertical, no angle. AD is going downward, AD times, sine 30, again minus DC times, sine 30 it's gonna be 0. So I'm gonna plug those numbers, dB minus AD, what is it? 4.1 times, sine 30 is what? Sine 30, half. Yes. DC sine 30 half. So what happens? This one is 4.1. So dB will be 4.1 kN, and that is also tensile. Okay. So we found dB. What else? dB, we can, BD or dB is the same, 4.1 or 0.01 kN tensile. Next is to look at, can you tell me which point should be focused? We need to find AB. Should we look at here? Here? This one? Point A. We are, we want to find the internal force here. You can do this, you can do this. Either is fine. Let's go with A. Point B. Remember, you have to draw that free body diagram for that point, whatever point you like, point B or A, draw it. Otherwise we don't know what you are doing, right? Point B has this force, which is 3 kN, and then it has 3 other forces, right? You have to draw the angle. This one. Can you tell me the angle here?
45.
The angle between this and this one.
45.
Somebody say 45. Everybody agree with that?
So
Because
Question.
yes.
How do you go through your process to determine if you're gonna pick point A or B? Like, what's the difference or advantage between choosing one over the other?
Okay, so you see, we found this, members, right? So the only member is AB.
Okay.
Then you're gonna see, that member is connected to which joint? It's connected to joint A, and it's also connected to joint, B.
Okay.
And this is a matter of, finding an easy way.
Okay.
So if there is no rule, you can pick point A to start, to find, this unknown force. You can pick, point B. Either is fine. You pick this one or pick this one. Either is going to give you the right answer. Okay. So I picked, point B. You can pick, point A and solve it. See whether we're going to came up with the same answer or not. Okay. So I picked, point B. And then what was this angle? 45, right? Why 45? Because, look, this is 2, this is 2. The angle, this angle is, y divided by x. Inverse tangent of, this 2. That is gonna give you, 45. So I put that one there, same thing here, this one is 45. And So these are tension. This one, BD was also tension. It's going downward. 5.0. Was it tension?
No, it's compression.
Oh yeah, compression. That was yes. So let's draw this way. So this, what is this one? A.
0.776.
No, we're gonna put the name here, and then we're gonna find this AB. And this one, this is BD, and that is 4.1. Is that right? Correct? Did I miss anything in there? So make sure you put the right information, because that is gonna be the basic. Fx, you have these two equations, and you pick which one you want to do. So I picked this one. I think with one equation we're gonna be done. Fx, what is Fx? 3 pure horizontal force. That's it. 1. And how about this one? We have to include it. 5 times cosine. That is negative 5.0 cosine 45. And this one AB, and it's going this direction, so it should be positive AB times cosine 45 positive, so 0. So you see, if you have this is a value, this is a value, only unknown is this one. AB times cosine, and I can write, I know cosine 45 is this. I can write it this way. I'm gonna take these two to the other side of the equation. What happens? Their sign is gonna change, right? 5.02 times this one. So if you do it, AB will be 0.77 kN, and that is compression. So you have to go to the next one. So, any question about this problem? Yes.
So in the graph on the top right, it's showing AB going towards the point. So that, would that make it tensile, going the other direction?
It's going this direction, and then when it's going that direction, it's going to be compressive. So that is the joint, right? If you want to draw, the elements, the element is here, right? You have to draw it this way.
Okay.
Right?
Yeah.
Okay. Any other question? So, make it a rule. Going to the point is going to be compressive. Going, force going to joint is going to be compressive. Coming from the joint is going to be tensile. So we have this problem. We need to find the forces in each member. How many members do we have? How many elements? 5. Everyone agree with 5? Yes. AB is 1. BC, CD, ED, and AD. And this is pin or roller. Point, C. what is it? Pin. How many forces? Two forces, X and Y. This is a roller. It's gonna be a force perpendicular to this, surface. So in thrust, initially you have to find the support reaction. Find those, forces at the support location. So that is the first step you have to do. Actually, before the support reaction, you have to draw the free body diagram. That is the initial step, right? So we can draw this one. So this is my force here, and I have this force, this one. I'm gonna write it this way. Point C, point B, point D, and point A. So force here is 400. Let's start.
Forgetting the 600 on D.
Oh yes, good point, thank you. Without that one, it's going to be completely wrong. 400. So, in order to find, this one, you can use, for finding the reaction, you can use all the, equation, equilibrium equation. Summation of forces in x, y, also summation of moment about any point. So I like to use, summation of moment at point C. At point C, then the forces, the unknown forces will be cancelled. There is no. Then I have only one unknown force here. I can find it, right? Summation. Summation of moment is very handy. It's gonna help you a lot. Summation of moment about point C. Then what do I have? So this is my point of interest. This one is making a rotation 400 times, the perpendicular distance, 3 meters, right? And that is negative, clockwise. 400 times, 3. This one, 600 times what? Times 4. Then this one is going this way, so it's counterclockwise, positive, and it is AY, right? What is that distance with respect to this point? Perpendicular distance. Yes?
Is the 400 going clockwise or counterclockwise?
Clockwise, this is my point. When you put, the element, it's gonna make, all counterclockwise. So this should be positive, this should be positive, this is gonna be negative. I'm sorry. Good point, thank you. So I have to change my sign here. AY times what? The distance? 6. Everyone agree with 6? F times D. 6. What else do I have? Nothing. 0. So one equation, one unknown. AY should be, let me see, I have that one, 600. N. So I can put 600 here. So we go one by one. Next is to find this one. Look, here if I use point A for summation of the moment, will I be able to solve both of them, to find both Cx and Cy? No, one equation, two unknown. It doesn't do. So I can use, summation of forces in x direction. Let's do that one. Fx 0. Fx, Cx, I plotted this direction, so Cx, and then I have 600 here, plus 600, 0. My Cx is 600. I draw this, I plot it here. Cx is 600. How about Cy? For the Cy, I can use Fy's, summation of Fy. What do I have? 600, this one, this 400, and this one is unknown. Positive 600, minus 400, and my C, as you see, is positive, Cy. What happened, my Cy is gonna be negative, 200. Yes?
Why is the CX negative?
Cx is not negative. Oh, because, no, I draw it this way, initially. It's going, negative direction.
Okay.
So initially it was negative, the direction. Yes. Okay, as you see, my C minus, Cy came up with a negative number. It means, this direction is wrong. So I have to reverse the direction. I can, change it, make it, this, 200, or I can use this one, minus 200. Okay? You can use this way or this way in the next calculation, in the next, summation of forces and moment, whatever later on you need. Okay? Did you get that point? What happened? Because in a negative value, then I can use this direction as is with this negative number. Later on, I have to use negative number, or I change the direction and make it positive with the 200. So I prefer to use this one. So going forward, I will use this force. It's going to be easier on a positive number. So far it was chapter 4. It wasn't chapter 5 yet, right? Whatever we did in this problem. Now we're gonna go to chapter 5. Yes.
Sorry, could you go over why the 600 is positive and 400 is negative in the initial equation?
600.
No, below that, sorry, for the F of Y.
F of 1. 600. What do we have? This one is going upward, the force, right? Positive.
Okay, so it's just, you're just doing that for direction, not as.
Yeah. No, that was our standard. We set the forces if they are going to, for the vertical forces. If they are going this direction, positive. X direction. If they are going this direction, it's going to be negative.
Okay, that has
Positive.
nothing to do with the counterclockwise and the clockwise method. That's.
Oh no, that is for the moment.
Okay, just for the moment.
For moment, counterclockwise. Counterclockwise gives you positive. Yeah, we can do some problem. My office come, my office. We can practice more. Okay. So I'm gonna finish this one so in time. What happened? We did only chapter 4 yet, right? So in chapter 5, we have to go joint by joint. This is section, method of joint. You have to go method of look at each joint and find the forces in each member. Okay. So you can pick this one. You can pick this one. If you pick this, it's going to be difficult. You have 3 unknowns. right? Is it, you know, good to go for that point? Doesn't make sense. You know, it's better to go with this one. How about this, you know, point C? Point C is very easy. You have two, you know, forces from here, and there is no angle, you know, this is horizontal, this is vertical, easy to solve, right? Let's go with, you know, point C. Point C, again, draw the free body diagram for point C. So what do I have? So look at, you know, that forces. I have 600, and then I have 200 going this direction, and then I'm gonna draw this forces, DC, and this is BC. Use this equation, f of x 0, so 600 negative is going this negative direction, and BC is going positive direction, 0. BC is 600. So my BC is 600, we found it. Then we go for the next equation, Fy0. We have minus 200 going down, plus, you know, DC 0. My DC is 200.
I thought you said you were gonna use positive if that is correct.
No, yeah, positive, the magnitude is positive. Now, in my equation, what's gonna happen? I'm gonna look at the direction, right? Yeah, it's a little confusing. You wanna use this one, that's fine. You wanna use this one, minus 200, then you have to bring that minus 200 directly here. Right?
Okay.
Note this one if you wanna use this. But, you know, I'm gonna use this one as the value, as a magnitude. And then I look at the direction where that, you know, force arrow is going. Then use this as my standard. So it's going downward, so I have to use the negative sign. Right?
Yeah.
Okay. What else? We found two forces, two members, you know, this member and this member. We can go to this point now because this one is, we know it, we can find, you know, we can go to point D. Point D, we have this forces, 600. And then what else? Just this should go downward, the opposite direction. We know this one has to be in equilibrium. So these forces, you have to decide whether you wanna make it positive, you see? Because, you know, look at this point D. This is important. If you wanna make, you know, a decision, which direction you should draw, engineering sense. If I, you know, this one is the only, you know, member that can carry, you know, vertical force, right? This has, you know, X and Y force, right? Both has angle. So this one can carry, vertical force, so it has to be opposite of this one. So this should cancel here, right? So now this is going this way. I have this force. This one, I can draw it this way. If I find negative, it can change. So this is point D. But again, you know, you can pick, you know, your arrow later when you find a negative value, you can change it. So what is this one? AD, right? How about this is 600, this one is DC, we have DC 200. And this one is BD. Okay,
Doesn't it have to be 600?
which one?
Be equal AD, since one's going to the right. and
How about this one? This also has, X component.
Yeah, it has an X component, but it also has a Y component for BD, right?
Yes, you have to include it, sometimes it may have, 200 in it, 200 in X component, then this is gonna be reduced.
Oh, okay.
You have to, construct this, fx 0. What I like to do, I'm gonna go with the fy first. You know why? Because in fy I have only this and this one. With one equation I can find BD.
Yeah.
Let's do that. 200 negative going downward. So I have bring that negative sign in there. BD, how about this BD? BD is going, this direction. You have to find